there. Today we're going to take a look at the midpoint formula. We're going to look at how to derive it and then how to use it. Let's go. Okay, so the midpoint formula is intended to allow you to take a line segment that starts at point 1 and ends at point 2 and figure out what the point that is exactly in the center is. So let's derive this formula. Let's say that we take our point 1 and we say that that is at x1 comma y1. And similarly, our p2 is at x2 comma y2. And let's say that our midpoint, m, is at x comma y. Okay, in order to derive this formula, I'm going to drop a vertical down from our midpoint and connect it up at a right angle to our point 1. And I'm going to do the same thing between point 2 and our midpoint. I'm going to draw a line parallel to the horizon and drop the vertical down from point 2, creating two right triangles. Now, by definition of the fact that it's the midpoint, I know that the hypotenuses are congruent. But what I also know, because this is a line and this is the horizon, I know that that angle will be congruent to that angle. And then I also know that in terms of my straight down verticals, that these top angles will be congruent to each other. And so by angle, side, angle, angle, side, angle, I know that these two triangles are congruent to each other. That means that in addition to the hypotenuses being congruent, this side will be congruent to this side, and this side will be congruent to this side. So now I can set up some formulas. If I then describe the length of this side as x minus x1, and I describe the length of this side as x2 minus x, and I've just established that those two lengths are equal to each other. And now if I go ahead and get my x on one side of the equation and everything else on the other side, I would add x to both sides, leaving me with 2x. And I would add x1 to this side. And finally, to solve for x by itself, I would divide both sides by 2. And that right there is the first half of my midpoint formula. The x coordinate of the midpoint is found by adding the x coordinates of my initial point and my final point and dividing by 2 or averaging them. Okay, if I repeat the exact same steps but with my y's, I find that y equals y1 plus y2 over 2, right? Exact same stuff, only we're doing it with our vertical side. And so that right there is my midpoint formula, that x comma y, my midpoint, is found by averaging the x coordinates of my 2 points, comma, averaging my y coordinates of my 2 points. Now, let's go ahead and apply this, and I'm going to jump straight to the most difficult application. If -1 comma 4 is the midpoint of line segment AB, and B is -3 comma 6, what is A? And students flip out. So here's how you do it. You separate your midpoint formula into two different formulas, one of which solves for x and one of which solves for y. So that would look like this. And now we're going to go ahead and throw our numbers in. So first of all, x. Well, that's the x coordinate of our midpoint. x1 and x2, well, one of them will be -3. The other remains our variable. And now we go ahead and solve for our variable. So I'd start by multiplying both sides by 2. Then I would add 3 to both sides. And I would find that 1 is the x coordinate of A. Now I'll do the same thing for my y's. Y, okay, that's the midpoint. So that's my 4 equals, okay, well, my y coordinate of my point B is 6, plus that's the thing I still don't know. And now I solve. Multiply both sides by 2, subtract 6 from both sides, and so my point A is 1, 2. And if I want a visual to just sort of make sure that's right, -1, 4 over 1 up 4. B, -3, 6 over 3 up 2 more. And now my A over 1 up 2. That's looking pretty correct. So it's always a good idea to plot them just to make sure you haven't made some wild arithmetic mistake. But that is the midpoint formula, how to derive it, and how to use it in its most complicated case. Okay, leave any questions you have in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.